Welcome back. Glad you're here. Take a breath. Settle in. Let the day slide off your shoulders. Tonight, we're slowing down. No rush. No noise. Just a question. What if Earth were designed? You don't need to answer right now. In fact, you don't need to answer at all. When we look at Earth, we see structure. Oceans breathe in tides. Seasons cycling on cue. Plants unfolding in spirals. Eyes, wings, lungs, all working just enough to keep life going. Is that design? Or just survival dressed up as design? That's the mystery. And tonight, we'll drift through it slowly. So, stay gentle with yourself. And if you'd like to spend more nights like this, more quiet questions, more slow science, make sure to subscribe. That way, you won't miss the next journey. When people say design, they usually mean intention, a choice, a plan, something shaped on purpose. Think of a chair. It doesn't just happen. Someone thought about height, comfort, balance. A person sat down and said, yes, this works. Or think of a clock, hands moving, gears turning, not by accident, but by a builder, a blueprint, a goal. It's simple, it's human. We see order, and we imagine someone made it that way. Now, take that same idea and stretch it out. Way out. Galaxies. If a chair has a maker, and a clock has a maker, what about Earth? What about the systems that keep life going? It's an old thought. Ancient. They felt rhythms in the seasons, and they asked, who arranged this? In many traditions, the answer was the gods, or spirits, or one great mind. Design meant purpose. Purpose meant meaning. Nothing was random. Every detail had a reason. Rivers flowed not just because of rain, but because they were placed to flow. Mountains rose not just from plates colliding, but because someone sculpted them. Life itself was considered a design, created to fit into a larger story. That way of thinking is natural. When we see order, our brains look for authorship. We see a pattern, and we think, who drew this? It's how humans make sense of the world. And here's the heart of the question. When we call Earth designed, do we mean it literally, as in someone or something built it piece by piece? Or do we mean it metaphorically, as in, the order feels so strong, it almost behaves like a design even without a designer? That distinction matters, because design, in the human sense, means foresight. It means a finished plan before the work begins. But the Earth we see looks different. It looks layered, reused, modified over time, not polished, but patched, not flawless, but functional. Still, the word design holds power. It whispers of purpose. It suggests that life isn't random, that the patterns we depend on are not just accidents, but intentional frameworks. That's why this idea lingers. Why does it feel heavy? Why does it show up in philosophy, religion, and even casual conversations? Because to say something is designed is to say it belongs, that it was meant, that it fits. So tonight, as we drift further, we'll hold that word gently, not to prove it right or wrong, but to see what it carries. Design, a simple word, a loaded idea, a doorway into the biggest questions of all. Look outside. Nature is full of shapes, not messy ones, but repeating ones, patterns that show up again and again. Think of a snowflake. 6 points, perfectly balanced. Every crystal is unique, but every crystal is symmetrical. It looks like something designed, almost hand-drawn. Or look at a seashell, a spiral curling inward. Not random, mathematical. It follows a ratio, a quiet formula hidden inside growth. The same spiral shows up elsewhere, in hurricanes, swirling across oceans. In galaxies, spinning in the sky, tiny shells and giant stars echoing the same curve. Coincidence? Or a sign of some deeper structure? Leaves follow patterns too. Branches split, then split again. A tree's veins repeat in the veins of a single leaf. Rivers spread out in the same way. Blood vessels mirror the same flow. Fractals everywhere. The same design, scaled up, scaled down. And look at animals. Butterfly wings with mirrored halves. A starfish with radial arms. A peacock feather with eye spots that seem painted. Even our own bodies. 2 arms, 2 legs, symmetry down the middle. Nature repeats itself in careful balance. Why? That's the question. Is it efficiency? Is it physics? Or is it an intention? Patterns feel purposeful. That's why humans notice them. A circle carved in stone looks deliberate. So when we see circles in flowers, in planets, in ripples across water, we wonder, is someone drawing these lines? Mathematics helps explain some of it. The Fibonacci sequence. Numbers that describe spirals in pine cones and sunflowers. Equations that capture how crystals grow, how waves spread, and how shapes form. Nature seems to obey rules, as if following a script, but rules themselves can feel like design. Who wrote them? Why these numbers, these ratios, these symmetries? Why do they appear across scales so wildly different? And yet, not everything is neat. Mountains crumble unevenly. Storms break patterns as often as they form them. Life isn't flawless geometry. It's rough. It's patched together. It balances between order and chaos. Maybe that's the secret. Patterns rise because they are stable. They survive. Spirals spread seeds evenly. Symmetry helps bodies move efficiently. Fractals carry resources through trees, rivers, and lungs. What works, repeats, and what repeats begins to look like design. To the human eye, these echoes are hard to ignore. They whisper of order. They suggest a purpose. They make Earth look less like an accident and more like a pattern itself. So tonight, we sit with that. Snowflakes falling in symmetry. Galaxies spinning in spirals. Veins and rivers branching in the same flow. The repetition feels like a language. A quiet one. One we are still learning to read. Not proof, not certainty, but a reminder that nature carries structure. That, in the middle of randomness, order blooms again and again, and that, by itself, feels intentional. Think about balance. Not perfect balance, but the kind that holds just enough. Earth is a master of that. Start with distance. We sit in a narrow band from the Sunday. Too close, and the oceans would boil. Too far, and everything would freeze. But here, water stays liquid. Seas form. Clouds cycle. Life can begin. The tilt matters too. Earth leans, just a little. Not upright, not flat. Tilt gives us seasons. Winter on one side, summer on the other. This rhythm shapes crops, migrations, and survival. Without tilt, the world might lock into sameness. A desert at the equator. Ice at the poles. But tilt keeps it turning, changing, alive. Then there's the atmosphere, a fragile skin of air. It holds warmth. It shields us from radiation. It carries oxygen for breathing, carbon dioxide for plants. Thin enough to let in light. Thick enough to block destruction. It was almost like it was measured out. The moon helps too. Its pull steadies our tilt. It keeps Earth from wobbling wildly. Without it, climates could swing into chaos. Too unstable for steady ecosystems. But the moon locks us in. Balance again. Water plays its part. So much of it, covering most of the planet. It regulates temperature, absorbs heat, moves energy across currents. Without oceans, Earth would be harsher, sharper, less forgiving. Even Earth's core matters. Molten iron is moving deep inside. It builds a magnetic field. That invisible shield blocks solar winds, Without it, the atmosphere might blow away. The surface stripped, bare, lifeless. When you stack all of these together, distance, tilt, air, water, magnetism, the picture feels delicate, as if Earth is balanced on a narrow ledge. A little to one side, and it collapses. But here it stands, steady enough to support life for billions of years. Science calls it a coincidence, a roll of cosmic dice that just happened to work. The right orbit, the right chemistry, the right timing, no intention needed. But balance like this feels different. It looks tuned, not perfect, but precise enough. Every piece leans on the others. Like a mobile hanging from the ceiling, push one part, and the whole thing shifts. And yet, it holds. So we sit here, breathing air, feeling seasons, drinking water, living inside this careful equation, a system that could have failed 1,000 different ways, but didn't. Coincidence? Calibration? The question lingers, not with urgency, but with quiet awe. Whether it was designed or discovered, Earth balances itself in ways that feel rare. Rare enough to notice, rare enough to wonder. And maybe that balance is why we're here at all. Earth feels steady, but look closer. It's both fragile and unbreakable at the same time. Life depends on thin margins, a few degrees of temperature, a balance of gases, water in liquid form. Shift any of these too far, and survival breaks. Volcanoes remind us. They erupt without warning. Ash clouds block the sunday. Lava reshapes the land. Whole regions can vanish in a day. Fragile. But life adapts. Seeds sprout in cooled ash. Forests return. Animals adjust paths. Resilient. Earthquakes crack the crust. Cities tumble. Mountains shift. A reminder that the ground beneath us is always moving. Fragile. Yet continents hold together. Oceans stay within their basins. The planet spins on. Resilient. Storms sweep the seas. Winds flatten forests. Floods erase valleys. Fragile. But rain refills rivers. Soil grows fertile again. Green returns where grey once ruled. Resilient. Even life itself shows this paradox. Species vanish. Extinction is constant. But new forms rise. Evolution continues. Resilience is written into change. Think about ice ages. Sheets of frozen water cover continents. Life retreats. Many animals die. Fragile. Yet humans endure. Plants wait beneath the frost. When the ice melts, the world blossoms again. Resilient. At every scale, Earth is both. The atmosphere is thin, easily disturbed. But storms, cycles, and feedback keep it circling endlessly. Fragile. Resilient. The oceans rise and fall. Tides are pulled by the moon. A storm can stir them into chaos. But the oceans themselves remain. They persist for billions of years. Mountains erode grain by grain. Rivers carve canyons. Fragile against time, but strong enough to last ages. Life depends on sunlight. One bright star, one steady output. If it flared too wildly, we would suffer. Fragile. Yet, stars like ours burn for billions of years. Resilient across cosmic time. This is the strange balance. Fragile in the short view. Resilient in the long run. We walk through disasters. We recover. The planet shakes, burns, freezes, and floods. And still, it carries on. Maybe this is why Earth feels designed. Because it holds life in a space so narrow, yet survives, blows so wide. It can break in moments. But it rebuilds across centuries. Fragile and resilient, both at once. And maybe that's the secret. Not perfection, not unshakable strength, but a system that bends, cracks, and still finds a way to continue. We live inside that paradox, breathing fragile air, walking on resilient ground, part of a planet that is always both. Some things feel too precise, too exact, too unlikely to be a chance. Physicists call it fine-tuning, the idea that certain numbers in nature are set just right. And if they were off, even a little, life wouldn't work. Gravity is one. Not too weak, not too strong. If gravity pulled harder, stars would collapse too quickly. If weaker, they might never form. No stars, no planets, no life. The strength of the electromagnetic force matters too. It holds atoms together. If it were different, chemistry itself would fail. Molecules wouldn't form. DNA would never exist. The strong nuclear force is another. It binds the heart of atoms. If it shifted slightly, stars couldn't forge the elements we know. Carbon, oxygen, iron, all gone, and without them, no living cells. Even the amount of dark energy matters. It drives the expansion of the universe. Too much, and galaxies fly apart before stars ignite. Too little, and everything collapses back in. But here we are, in the middle ground. The distance between Earth and the Sun feels fine-tuned too. A little closer, and oceans boil. A little farther, and they freeze. The habitable zone, a narrow band where water stays liquid. Even Earth's tilt matters. It gives us seasons. Without them, the climate would lock into extremes. Maybe too hot at the equator, too cold at the poles. But tilt brings balance. The moon stabilizes that tilt. Without it, Earth might wobble chaotically. Seasons would swing wildly. Life might never settle. Some scientists see design in this. A universe built with intention. Numbers chosen with care. Constants locked in for life. Others see selection. Billions of universes could exist. Most lifeless. But we're here because this one works. We can only notice fine-tuning in a place where life survives. It's a deep question. Are we lucky? Or are we meant to be here? Fine-tuning feels fragile. Change a decimal, and everything falls apart. But it's also steady. The constants haven't shifted for billions of years. Stable enough for stars, planets, and people. Maybe that's the real wonder. Not whether the universe was designed, but it holds together at all. Those numbers, invisible and silent, let atoms dance. Let stars burn. Let life ask questions. Fine-tuning doesn't give an answer, but it sharpens the mystery. Why do the laws look so exact? Why does just right even exist? We can't say for sure, but lying here, breathing, alive, we are proof that the constants work. Maybe it only looks designed, because we are here to see it. That's the idea behind coincidence, or what some call the anthropic principle. It sounds complex, but it's simple. Imagine rolling dice. Most of the time, you don't get sixes, but once in a while, you do. If life depends on rolling sixes, then of course, we find ourselves in the universe where the dice landed that way. It feels special. It feels unlikely, but it's only unlikely until it happens. After that, it's the only roll that matters. In the same way, Earth seems perfect. Distance from the Sunday, oxygen in the air, liquid water, stable climate, all tuned for life. But maybe it's not tuned. Maybe it's just a chance. The universe tries countless combinations. Most don't work. But we don't see those. We only see this one, because it worked. It's like a lottery ticket. The odds are tiny, but someone always wins. And when they do, it feels amazing. Special, even meant to be. But in truth, it was inevitable that somebody would win, eventually. If there are billions of stars, trillions of planets, maybe endless universes, then it's not strange that one of them looks just right. We live here because we couldn't live anywhere else. That's a coincidence. No purpose. Not designed. Just survival bias. Still, it feels uncomfortable, because coincidence doesn't answer why. It doesn't comfort. It doesn't inspire. It only says, this is what worked. And yet, coincidence is powerful. It explains why the universe feels so precise without requiring a designer. It explains why we're surprised by patterns when patterns are necessary for us to exist. Even consciousness could fit this view. Brains evolved because they helped survival, not because the universe wanted thinkers, but because on the long roll of cosmic dice, intelligence was one path that happened to work. Coincidence doesn't mean meaningless. It just means unplanned. Meaning can still be made. By us, some see beauty in that. That out of randomness came order. That out of chaos came life. The universe didn't need a script to write our story. Maybe we're not here because Earth was chosen. Maybe we're here because Earth just happened to work. And the fact that we can ask the question, was it design or coincidence, shows how far chance has carried us. Coincidence doesn't close the door, it opens one. It lets us imagine how many other worlds might exist, how many might be empty, and how rare it is that we're not. Whether designed or discovered, planned or lucky, the fact remains, we are here. And maybe that's enough. Sometimes complexity doesn't come from design. It comes from simple rules, repeated, interacting, over time. That's emergence. Think of a flock of birds. No single bird commands. No blueprint. Just a few instincts. Stay close. Don't collide. Follow movement. And suddenly patterns. Waves through the sky. Arcs and spirals. Shapes that look choreographed. But no one designed them. The same is true with ants. One ant follows a trail. Another follows that ant. Pheromones strengthen the path. Soon, a line forms. A colony moves as one. Emergence looks like planning, but it's not. It's an order from interaction. Now, stretch that idea bigger. Rivers carve valleys, not by intention, from water meeting rock. Gravity is pulling down, flow repeating. The landscape sculpts itself. Or think of snowflakes. Every crystal is unique, but the rules are simple. Temperature, moisture, molecular bonds. The rest unfolds. Life itself may be an emergent system. Molecules combine, recombine, patterns form, cells appear, not from a master plan, but from physics and chemistry repeating over time. The brain too, billions of neurons. Each firing, each follows electrochemical rules, and somehow thoughts arise. Memories, dreams, awareness. No central switch, no top-down design, just emergence. When people see this, they often ask, is this less special? Does emergence make life accidental? Or does it make it more remarkable? Because, think about it, simple rules, unfolding into oceans, forests, civilizations. That's breathtaking. Emergence explains why systems don't need perfect design. They can shape themselves. Feedback loops refine. Structures adjust. Over time, stability grows. But not always. Emergence also creates chaos. Traffic jams, market crashes, storms from shifting winds, beauty and disaster, born from the same principle. It shows us something about Earth. That maybe the patterns we see aren't designed in advance. Maybe they rose naturally. Gravity and chemistry, trial and error, feedback shaping complexity. And if that's true, then our world isn't a crafted machine. It's a living process, a system that built itself, layer by layer. Whether we call that chance or inevitability, it leads to the same place. A planet alive with complexity, a species able to wonder how it happened. Emergence doesn't erase mystery, it deepens it. Because if so much beauty can arise from so little, what else might simple rules create? Given enough time, and here we are, part of it, not above it, not outside it. Just another emergent pattern, learning to see the ones around us. When people imagine design, they often imagine perfection, smooth, efficient, without mistakes. But nature doesn't look like that. It carries flaws. strange detours, awkward compromises. Take the human eye. It's powerful, yes. It lets us see color, movement, detail, but it also has a blind spot. Where the optic nerve exits the retina, there's no vision at all. If this were a blueprint, wouldn't that gap be fixed? Wouldn't the wiring run behind, not across the field of view? Other creatures solved it differently. An octopus eye has no blind spot. Its wiring runs the opposite way, clearer, cleaner, more direct. So why are we left with this design? Because evolution works with what exists. It reuses. It modifies. It doesn't start fresh. The eye we have is good enough. Not perfect. Not optimal. Just workable. And the eye isn't alone. Look at the spine. Built first for animals, on 4 legs. Repurposed for upright walking. Strong enough, but prone to pain. Discs slip. Curves strain. A constant reminder that we're carrying old solutions into new shapes, or the throat. Breathing and eating share the same passage. That means choking is possible, a risky compromise, but again, good enough. Not elegant, not flawless, simply functional. These imperfections don't look like blueprint mistakes. They look like trial and error, like adjustments layered over time, solutions patched onto older ones. That's how evolution works. It doesn't throw out what doesn't fit. It bends it, twists it, adapts it into something usable. Sometimes awkward, sometimes brilliant, always temporary. Imperfection itself becomes evidence, not of a grand plan, but of a process. One that values survival over symmetry, function over finesse. And yet, there's beauty here too, because flaws tell stories. Every strange bend, every fragile joint is a record of where we came from, a map written in bone and nerve. If Earth were perfectly designed, would it carry so many compromises? Maybe not. But if Earth emerged, piece by piece, through countless experiments, then imperfection is exactly what we'd expect. And somehow, imperfection doesn't make it less amazing. It makes it more. Because despite the blind spots, the back pain, the choking hazards, we see, we walk, we breathe, we think. Flawed systems still work. They still build worlds. They still create lives capable of asking questions like this. So maybe imperfection isn't failure. Maybe it's proof of how life really grows. Not from a flawless plan, but from persistence, from adjustment, from millions of small fixes that together become survival. When we think of design, we picture a blueprint, a clean sketch, lines drawn with purpose, a final version crafted before it's built. But evolution doesn't work like that. It doesn't design. It tinkers, step by step, piece by piece, using what's already there. Think of it like repairing an old machine. You don't throw it out. You add a new part. You adjust, you rewire. It runs. Maybe not perfectly, but just enough to keep going. That's how life builds itself. Not from scratch, but from hand-me-downs. From parts borrowed and repurposed. Take wings. Bird wings weren't made in one step. They began as arms, covered in feathers, meant for warmth and display. Later, those same feathers caught air, lifted, carried, and the flight began. Or lungs. They started as swim bladders in fish, organs for floating. But when some fish moved to land, those bladders changed. They are filled with air. They became the lungs that let creatures breathe above water. That's tinkering, not foresight, not clean engineering, but reuse, adaptation, trial and error stacked across time. Even the human brain is a tinker's masterpiece. At its core is the reptile brain, handling movement and survival. On top of that, the mammal brain, emotions, memory and care. And layered again, the neocortex, language, planning and reflection. Not a single plan, Not one fresh design, but layers on layers, wired together, sometimes smoothly, sometimes awkwardly. It's why instincts and logic clash, why emotions override reason. Because the wiring wasn't laid out properly. It was added on top of what already worked. Evolution tinkers because it must. It can't see the future. It can only use what survives the present. A broken piece that still functions gets passed on. A clumsy structure that works sticks around. The result isn't perfection. It's persistence. A kind of rough resilience. And maybe that's the lesson. Earth doesn't look like a clean design because it isn't one. It looks like a workshop, a place where parts are tested, kept if useful, discarded if not. It looks messy up close, but step back and you see something else. The mess builds. It stacks. It accumulates into ecosystems, into bodies, into minds. Tinkering doesn't produce elegance, but it produces life. Life that works. Life that lasts. So when we look at Earth, we don't see a flawless plan. We see billions of years of tinkering, failures and fixes, accidents turned into opportunities, repairs that became revolutions, not blueprint design, but something just as powerful, something that shows what persistence, trial, and time can really create. If Earth were designed, a question lingers. Why like this? Because this version of life isn't flawless. It works, mostly, but it's far from perfect. Bodies break down. Spines ache under upright posture. Eyes have blind spots. Joints wear out. The brain, for all its brilliance, is vulnerable to confusion, addiction, disease. If this were a blueprint, why these flaws? Why not smoother, stronger, cleaner? Nature doesn't look like a polished plan. It looks like a compromise. Trade-offs everywhere. Strength at the cost of fragility. Speed at the cost of safety. Intelligence at the cost of anxiety. Think of childbirth. For humans, it's dangerous and painful. Why design it that way? Because walking upright narrowed the hips. Because big brains needed larger heads. Two solutions collided. The result? A compromise that works, but just barely. Think of the throat. Food and air share the same path. A risky shortcut. It means choking is always possible. Efficient? Maybe. Elegant? Hardly. Think of ecosystems. They thrive, but they collapse too. Forests burn. Oceans acidify. Species vanish. Balance is real, but it is fragile. If this is a design, it doesn't feel like perfection. It feels like a system that allows failure, even requires it. Evolution explains this. Imperfect structures survive because they're good enough, not flawless, just functional. The spine wasn't redrawn from scratch. It was repurposed from four-legged ancestors. The eye wasn't engineered cleanly. It was patched and improved over time. That's why imperfection lingers. But if we hold to the idea of design, the question sharpens. Why would a designer allow such flaws? Why not make a world without suffering, without collapse, without risk? Maybe the answer is in trade-offs. A perfectly safe system might never change. A perfectly efficient body might never adapt. Fragility forces resilience. Scarcity drives cooperation. Failure sparks innovation. That doesn't make it easy. It just makes it possible. And maybe that's the unsettling part. If Earth were designed, it wasn't designed for perfection. It was designed for survival, for continuation, for stories that keep going, even when parts break. So the question remains, why like this? The science points to evolution, tinkering, compromise. But even in design, the imperfections tell us something. That beauty can come with flaws. That strength carries weakness. That survival doesn't require elegance, only persistence. Maybe Earth looks the way it does because this is what works, not the best. not the cleanest, but enough. Enough to hold life, enough to let us reflect, enough to make us ask the question at all. Every system has trade-offs. Nothing in nature is free. The human spine lets us walk upright. It freed our hands for tools. It gave us height, vision, and endurance. But the cost is pain. Discs slip, nerves pinch, backs fail with age. A brilliant adaptation, with a painful weakness built in. The eye sees with clarity. It guides us through light and dark. It gives color, detail, and motion. But it also has a blind spot. A place where nerves block the view. Not an elegant design, more like a patch that worked well enough. Nature is full of these compromises. Powerful jaws, but teeth that rot. Quick reflexes, but fragile bones. A brain capable of reason and art, but also anxiety and despair. Trade-offs don't stop with the body. They stretch across ecosystems too. Forests grow, rich with life, but they burn easily. Fire destroys, yet it also clears space for renewal. Collapse becomes part of the cycle. Oceans teem with species, but they depend on delicate balances. Temperature shifts, currents change, and whole systems unravel. Coral reefs are strong until they bleach. Fish populations thrive until they crash. Nature rarely optimizes for perfection. It optimizes for survival. A good enough solution beats a flawless one that takes too long. Think of evolution as tinkering, not a master engineer, a trial and error mechanic. Something works? Keep it. Something breaks? Replace it slowly, layer by layer. Small fixes pile up. The result isn't neat. It's effective. That's why we live in a world, both resilient and fragile. Life bounces back from disasters. Species adapt. Ecosystems reform. But always with trade-offs. Always with costs. Even cooperation has them. Wolves hunt together. They succeed as a pack. But competition within the pack creates tension and struggle. Plants reach for sunlight, but every tall tree casts shadows. For one species to thrive, another must give way. The deeper you look, the more you see this pattern. Nature's balance isn't smooth. It's jagged, a dance between benefit and cost, gain and loss. So, if Earth was designed, it was not for perfection. It was for persistence. Systems that bend, sometimes break, but rebuild in new forms. Trade-offs are the engine. They create diversity. They force adaptation. They make room for change. The spine that aches also made cities possible. The eye that fails still paints art. The reef that dies can seed a new one. Fragile, yes, but also enduring. That's the strange gift of trade-offs. They remind us that imperfection can still hold beauty. Those flaws don't always mean failure. That survival doesn't require perfect design, only enough to continue. Life survives, not because it is perfect, but because it bends. Perfection breaks. It shatters under pressure. Life doesn't need perfection. It needs resilience. From the very beginning, life adapted. Cells learned to repair. They copied themselves, sometimes with errors. Those errors became changes. Change became survival. Think of the cockroach. It thrives in ruins. Not pretty, not flawless, but durable. Think of moss. It creeps across stone. Thin, fragile, yet steady. It grows in places nothing else dares. That's resilience. Even humans tell the same story. Our bodies falter. We age, break, and weaken. Yet, across thousands of years, our species persisted. Because we adapt, because we learn, because we change. Ice ages froze the land. Humans made fire. Droughts emptied rivers. Humans migrated. Predators stalked the dark. Humans hunted together. Not perfect, durable. This is the deeper truth of life. It doesn't win by flawless design. It wins by trying again, by absorbing the hit, by continuing. Ecosystems prove it too. Forests burn, they grow back, seas shift, new species rise, mountains erode, valleys form, the pattern repeats, always breaking, always reforming. Durability means patience. It means not relying on a single path. It means flexibility. When one branch snaps, another carries the weight. We see it in DNA. Mutations pile up, most do nothing. Some fail, but a few help. A tiny tweak that keeps a species alive. That's not perfection. That's persistence. And maybe that's the secret. Earth's story isn't about a flawless system. It's about one that can take damage and keep going. Durability over design. Adaptation over purity. Survival over symmetry. So, when we ask, was Earth designed? Maybe we should ask instead, why does it endure? Why does life continue through fire, ice, and collapse? Because perfection wasn't the goal. Endurance was. And here you are, listening, breathing, part of a lineage that bent but didn't break, part of a chain that survived storms, extinctions, and change. You are proof that resilience works, that durability carries forward, that even imperfection can create continuity, and that is worth reflecting on. Not perfection, but persistence. Not flawless, but lasting. So, if this journey feels calming, if these thoughts bring you peace, stay with us. There are more quiet questions to explore. Subscribe, and let's keep wondering together. Up close, life looks messy. Cells mutating, species fighting, ecosystems collapsing. It feels chaotic, unplanned, fragile. But zoom out, step back, look from above. The mess starts to blur. Randomness fades into pattern. Disorder folds into order. A river twists wildly. Up close, it seems aimless. But from the sky, it carves a shape. A basin, a valley, a path that guides life. The same with forests. One tree falls, another grows. From the ground, it's destruction. From afar, it's renewal. Even mass extinctions. Close in, they look like endings. Terrible loss. Dark silence. But across millions of years, they open doors. New species rise. New branches spread. Chaos up close. Structure from distance. Think of an ant colony. Each ant looks frantic. Running, carrying, searching. But step back, and there's a city, roads, divisions of labor, networks that function. Or think of galaxies. Stars explode, planets collide, gas clouds collapse. A storm of fire. But look across billions of light years, and its elegant spirals. Symmetry, balance. This is how scale changes perspective. What feels broken may actually be fitting. What feels random may be part of a larger rhythm. Even our lives, day by day, they feel scattered. Moments of struggle, moments of joy, moments that seem pointless. But over the decades, a shape emerges, a story forms, connections appear. Zooming out reveals continuity, patterns hidden by closeness. Maybe Earth is like that, not perfectly designed, not flawlessly balanced, but resilient at scale. Disasters hit, species vanish, continents drift, but the whole keeps moving forward, not smooth, but steady. So maybe design isn't in the details. Maybe it's in the overview. The way small pieces add up to something enduring. The universe doesn't hide its scars. Planets are cratered. Stars collapse. Life stumbles. But zoom out, and those scars become texture. Part of the fabric. What once looked messy, now it looks inevitable. What once looked broken, now it looks complete. That's the gift of perspective. Up close, it's noise. From afar, it's music. So, When you think of Earth, its storms, its faults, its flaws, try zooming out. See the long arc, see the broad canvas. It may not be perfect, but it is coherent, it holds together, and it carries us forward. Not chaos, not designed, but something in between, something only visible. When you step back, time changes how things look. Not hours, not days, but centuries, millennia, eras. Zoom into a single year, and you see storms, droughts, floods, fires. It feels like chaos. Zoom out thousands of years, and patterns appear. The climate is not steady. It breathes. It warms. It cools. Glaciers advance. Glaciers retreat. What feels like a crisis in a lifetime is rhythm in deep time. A pulse of ice and melt. A cycle of drought and rain. Balance, but not stillness. Life moves to that rhythm. Species expand, then vanish. Extinctions wipe the slate. Renewal writes on it again. The dinosaurs ruled, then they fell. A fiery ending, but also a beginning. Mammals stepped forward. Forests shifted. Oceans filled again. Every extinction has left openings. Every collapse has seeded renewal. Even small scales echo this. A forest burns. Ash covers the ground. It looks destroyed, but seeds sprout. Soil replenishes. In time, a new forest rises. Death feeds life. Loss clears space. Cycles continue. The same with oceans. Coral reefs bleach. Fish vanish. But over centuries, reefs return. Not the same, but alive again. Earth is not fragile glass. It's flexible rhythm. It bends. It breaks. It heals. But healing takes time. More than human lives. More than human memory. That's why perspective matters. We see disaster. Earth sees renewal. We see endings. Earth sees cycles. This doesn't mean it's easy. For species caught inside the collapse, there is no return. The doesn't token. For us, living in the short view, loss feels final. But step back, and you see the pattern. Life adapts. Systems reform. Different, yes, but still moving forward. The ice ages came and went. Each reshaped continent. Each reset ecosystems. But each time, life continued. The same for warming. The same for cooling. The same for shifting seas. Not smooth, not gentle, but constant. Cycles of climate. Cycles of extinction. Cycles of renewal. This is Earth's long story. Messy up close. Elegant in the sweep of time. Maybe that's why patterns comfort us. They tell us that chaos is temporary. That endings are preludes. That life doesn't stop. It shifts. Our role is small. Our time is short. But we are part of this rhythm too. Breathing in sync with forests. Eating from oceans. Building on land that was once the seabed. The cycles will continue, with or without us. That truth is humbling, but also steadying, because in a world that feels unstable, patterns remind us this has happened before, and still, life found a way forward. Not perfection, not permanence, but renewal, over and over and over again. Patterns are everywhere. Spirals in shells, branches in trees, cycles in climate, extinction, renewal, extinction again. The question is simple. Do these patterns mean design, or are they the natural result of the process? When we say design, we usually mean intention. Someone planned. Someone chose. Like an architect drawing blueprints. Like an engineer building a machine. But the process is different. It doesn't plan. It doesn't choose. It repeats. It tests. It leaves behind what survives. Think of a river. No one designs its curves. The water just flows. Over time, it carves, bends, and channels. The shape looks deliberate, but it's only a process. Or think of crystals. Snowflakes form with symmetry. They look carved by hand. They aren't. They're just molecules, arranging themselves under the rules of physics, order without a designer. So when we look at Earth, its cycles, its systems, are we seeing blueprints? Or are we seeing rivers and snowflakes, patterns that arise because they must? It could be either. It could even be both. If Earth is designed, then the designer worked subtly. Not neat, not perfect, but layered, flexible, full of trade-offs. A design that allows surprise. A design that bends with time. If Earth is a process, then that too is remarkable. Because of blind repetition, came forests, came oceans, came minds that asked this question. Maybe the patterns are just efficient. Maybe spirals, branches, cycles are the simplest solutions. Physics favors them, chemistry favors them, life builds with them. Or maybe the patterns point deeper, to the intention hidden in the rules, to structure a set from the beginning, to a system that doesn't just happen, but unfolds according to plan. The problem is, from where we stand, the two look the same. Design can look like a process. Process can look like design. Both create order, both create structure, both create forms that repeat across scales. So how do we know? Maybe we don't. Maybe knowing isn't the point. Maybe the power is in asking, in seeing that order exists at all. Because whether Earth is designed or simply the product of a process, the outcome is astonishing. A planet that cycles, a world that sustains, a system that gives rise. To creatures who wonder, the distinction matters less. When the result is the same, we are here, we are alive, we are watching patterns unfold. That in itself is worth pausing for, worth marveling at. Design, process, intention, accident. Maybe the truth sits between them. Maybe what we call design is just a process seen from above, and what we call process feels like design because it creates beauty without trying. Either way, the question remains open, and sometimes open questions are the best kind to fall asleep with. It's a strange idea, but it keeps coming back. What if Earth itself, is it a simulation, not a metaphor, not science fiction, but a real, programmed environment running on some hidden substrate? The thought begins with computers. We build models. We simulate the weather. We simulate galaxies. We simulate evolution. And already, those simulations look surprisingly lifelike. Agents move. Populations rise and fall. Patterns emerge that no one coded directly. Just rules. Just conditions. And complexity unfolds. So, the question follows. If we can simulate small worlds, why couldn't someone simulate large ones? Even a universe, even Earth. Some philosophers argue that if civilizations survive long enough, they will eventually build simulations so real that conscious beings emerge inside them. And if that's possible, then statistically, there could be far more simulated worlds than the original ones, which means we might already be in one. There's no proof, but there are oddities. Physics seems pixelated. Energy comes in quanta. Matter has limits of resolution, like the smallest possible length, the smallest possible time, almost as if reality has a grid. Then there's observation. Particles behave one way when unmeasured, another when observed. Like the system only renders detail when someone looks. Are these signs of computation, or just the nature of physics? We don't know. If Earth is a simulation, then the design is real. Every constant, every law, every cycle, chosen, coded, maintained by something outside. But if it is, why like this? Why floods? Why disease? Why imperfection? Wouldn't a designer remove the flaws? Unless the flaws are the point, unless struggle, chance, and limitation are part of the program. A way to keep it interesting, or to keep it evolving. Maybe Earth is not a polished blueprint. Maybe it's a test, or an experiment, or even entertainment. We can't say. And maybe that's the beauty of the idea. It doesn't give answers. It opens a perspective. If reality can be simulated, then the line between design and emergence blurs. Between creation and discovery. Between built and grown. But here's the quiet part. Even if Earth is a simulation, it doesn't change the way it feels. The rivers are still rivers. The stars are still stars. Our breath, our thoughts, our questions, they are still ours. So, whether this is the base reality or a coded one, the wonder doesn't vanish. It might even deepen, because in that frame, every sunrise, every heartbeat, every spiral in a shell is not only natural, it's also a line of code, beautiful enough to live inside. Look closely at the universe, not with your eyes. With equations, with experiments, with tools built to peel back layers, what do we find? Limits, boundaries, rules that feel strangely familiar, almost like code. Energy is not smooth. It comes in packets. Quanta, light is both a wave and a particle, but only in certain steps, never in between. Space is not infinite in detail. It has the smallest length, a scale so tiny we can't cut it smaller. Time is not a perfect flow. It ticks in intervals, like frames on a screen. These are not guesses. They are what physics shows. Experiments repeat them over and over. The universe behaves as if it has resolution, as if reality is pixelated. Think about matter. Solid, heavy, permanent, or so it seems. But beneath, it's mostly empty space, particles held by fields, probabilities, not certainties. And those probabilities, collapses only when measured, observed, like a computer rendering a scene, only when a player turns their head. It raises the question, are these just quirks of physics, or are they hints of something deeper? Something digital, something structured. In our machines, rules create worlds. In games, trees sway, oceans crash, light bends. Not because those things are real, but because the code says so. Could physics be the same? A set of instructions, constants, algorithms, executed perfectly, everywhere, always. The speed of light, the pull of gravity, the strength of the strong force, unchanging, as if defined once, then locked in place. But here's the twist. Even if it is code, it doesn't feel like it. We don't walk through pixels. We walk through forests. We breathe air. We taste water. We fall in love. The laws underneath might be mathematical, but the experience on top is lived, and no equation can take that away. So maybe physics is a program, or maybe it just behaves like one. Either way, the pattern is the same. Rules lead to structure. Structure leads to stability. And within stability, life finds a foothold. That's the quiet miracle. Whether written as code or written as nature, it works. It lasts. It allows us to ask these questions, while sitting inside the system itself, not bad for a universe. That might be running on lines we can't even see. Every system has edges. A screen has pixels. A map has borders. A game has limits. What about reality? Does it have edges too? Look at physics. The speed of light. Nothing faster. Why a cap? Why not infinite speed? It feels like a frame rate, a maximum pace, built into the system. Look at space. Zoom in close. Smaller and smaller. Particles vanish into uncertainty. No infinite detail. Just a fuzz. Like resolution breaking down. When you press your face against a screen, look at the matter. It comes in steps. Electrons jump orbits. Energy moves in packets, never in between, as though nature uses shortcuts. Efficient, tidy, not continuous. Even coincidences feel like edges. The moon is 400 times smaller than the Sunday, but also 400 times closer, so they appear the same size in the sky. Perfect for eclipses. Too neat to ignore. A strange alignment, just right for observers. Or think about constants. Gravity's strength. The charge of the electron. Numbers that don't drift. Numbers that stay fixed. Not one decimal off. Like values set in a program. And then there's quantum behavior. Particles don't exist until they are observed. Or maybe they exist everywhere until they collapse into one outcome. Either way, it feels like rendering, like a world filling in, only when someone looks. Of course, these could just be physics, the way the universe island, edges that aren't edges, limits that aren't programmed, just natural rules. But the resemblance lingers, the glitches, the shortcuts, the strange coincidences. They whisper of structure, not proof, but hints. If you've ever played a game, you know the feeling. Run far enough, and the map ends. Walk close enough, and textures blur. Sometimes you even see the seams, a crack between worlds, where design shows through. In reality, we don't see cracks, but we see boundaries, points where things stop, points where things refuse to go further, like the edge of possibility itself. What does that mean? Maybe nothing, maybe everything. Maybe it's a sign that reality is finite, structured, bounded, not infinite chaos, but a system with edges, carefully held together. Or maybe it's just us, searching for patterns, finding meaning in the rules. Because that's what we do. We look for seams, we look for signs, we look for edges. And the universe, maddeningly, always gives us just enough to keep asking. So let's imagine, what if Earth really is a simulation, not a metaphor, not just like a system, but an actual programmed environment? What would that mean? First, it changes the question of origin. No longer, where did the universe come from? Instead, who pressed start? A designer? A civilization? Something beyond what we can picture? It also changes scale, because if one simulation exists, others could too. Nested realities. Worlds inside worlds. Layers running on top of each other. Which layer are we in? Maybe not the first. Maybe not the last. Then, there's meaning. If life is simulated, does it matter less? Or does it matter more? A test? An experiment? An artwork? We don't know, but the idea itself shifts the weight of existence. Now think about rules. In a simulation, laws are not eternal. They are settings. Gravity, speed of light, the constants of physics, all parameters. Someone chose them, or something did. Not random, but configured. And what about us? If we are simulated, are we real? The body feels real, pain feels real, love, loss, joy, memory, all real to us. Even if the substrate is code, experience is still experience. Consciousness is still consciousness. But it's unsettling too, because in simulations, things can be paused, rewound, reset, deleted. What happens to us if the program ends? Some thinkers suggest that advanced beings would never bother simulating random rocks. They would simulate observers, minds, civilizations. That means you, sitting here, might be the main product, not the background. It also raises the question of purpose. Why run a simulation at all? Curiosity? Entertainment? Research? Or maybe no reason, other than the possibility itself, the unsettling part. We could never be sure. A simulated mind cannot easily step outside the system. To confirm it, the rules of the simulation Keep the curtain closed. Still, the signs tempt us. Edges, coincidences, limits. They spark the thought. That maybe this isn't all their island. That maybe, behind the stars, there's code. Behind physics, a framework. Behind reality, something else entirely. But here's the grounding thought. Even if it's a simulation, our choices matter. Our lives matter. Because meaning isn't only about origins. It's also about experience. And whether it's code or chemistry, we still laugh, love, dream, wonder. So maybe the simulation question isn't about proof. It's about perspective. It asks us to see reality, not as guaranteed, not as ordinary, but as fragile, remarkable, and temporary. And if it is temporary, that's even more reason to value it now. If Earth might be a simulation, it's worth turning the mirror back, because we too are now building simulated worlds. Think about games, digital landscapes, places coded from nothing that feel alive once you step inside. Cities with traffic, oceans with waves, characters who move, breathe, react. They aren't real, yet to the player, they feel like they are. Then think about virtual reality. Put on a headset, and you're standing somewhere else. On a mountain, in deep space, inside a painting. It fools the senses. Eyes, ears, and even balance. Your body says, this is real, even though part of you knows it's only pixels and sound. We design systems with rules of their own. Physics inside a game engine. Economies in online worlds. Communities forming in chat rooms. Each one runs like a mini-universe. Predictable, yet surprising. Structured, yet full of accidents. It doesn't stop there. Think about the simulations we use for work. Climate models, flight simulators, population forecasts. They're built to test possibilities. What if the temperature rises? What if the plane stalls? What if the numbers shift? Each one creates a copy, a reflection of reality to help us navigate the future. And every year, those simulations grow sharper, more detailed, more convincing. They blur the line between play and reality, between testing and living. Why do we do it? Partly for learning, partly for safety, partly for imagination. We simulate to see what might happen. Before it happens, we design because we can't help but create. And in doing so, we echo the very idea we're exploring. If our worlds can be simulated, why not ours? If we can build smaller systems, who's to say there isn't a larger one above us? What's striking is this: to the characters in our worlds, if they could think, their reality would feel complete. They would have no reason to believe it was constructed. The edges of their simulation would be invisible, just like ours, if it exists. So here's the twist. By creating simulations, we show ourselves how convincing one can be. We see how rules, how feedback, how randomness can combine into something that feels alive. It makes the question sharper. If we can build worlds, why not expect that others could? And if others could, who's to say they haven't? So, the act of designing, the act of simulating, it isn't just technology. It's philosophy. It teaches us how easy it is to blur real and unreal, and how fragile the line between the two really island. Step inside a game world. Characters move. They gather. They fight. They react when you act. At first glance, it feels like intention, as if they have goals, as if they're alive. But look closer. It's code. Lines of instructions. If this, then that. Decision trees. Algorithms. Nothing more. Yet something strange happens. When enough rules stack together, the behavior looks natural, surprising, even human. Think of an AI opponent in a strategy game. It builds armies, expands cities, chooses when to attack and when to retreat. It doesn't know why. But to you, it feels like it does. Or watch a group of digital birds. Each one follows 3 simple rules. Keep a distance. Match speed. Stay close. From those basics, a flock forms. Waves and swirls across the sky. No leader. No master plan. But still, a pattern emerges. That's the heart of it. Agents in digital spaces don't need awareness to seem intentional. They just need rules and interaction. And once they interact, things appear. Patterns, behaviors, stories. Sometimes, even the creators are caught off guard. Developers watch their programs and see outcomes they didn't fully predict. Creatures adapting, characters taking strange paths, systems evolving beyond the original blueprint. It can feel eerie, as if the machine has learned, as if the code wants something, even when it doesn't. And now, with modern AI, the illusion grows stronger. Chatbots that talk, avatars that act, agents that negotiate, cooperate, and compete. The line between scripted behavior and genuine decision-making gets harder to see. So, here's the thought. If we can create agents that only looks intentional, what does that say about us? Are we following simple rules? At a higher scale, genes, chemistry, physics, playing out interactions that appear purposeful. When seen from above, maybe the feeling of design comes from that, from the way simple parts combine into complex wholes, from the way behavior seems like a choice, even when it's a rule. In digital spaces, we see a reflection of ourselves, artificial beings that move as if alive, not conscious, not aware, but still stirring the question, how much of life is truly chosen, and how much? Is it only the dance of rules? Agents in code remind us, intention can be an illusion, but the illusion is powerful. It feels real, and maybe, in the end, that's all the intention needs to be. Look at a fern leaf. Tiny branches repeat the shape of the whole. Each leaflet is a copy, smaller, but the same. That's a fractal, a pattern within a pattern. Look at a seashell. The spiral winds outward, never ending, always expanding. The same curve shows up in galaxies, in hurricanes, in the path of a hawk circling the sky, spirals across scales. Or consider your heartbeat, not steady like a metronome, instead a rhythm of variation. Beat to beat, it adjusts. Feedback loops, signals from your brain, your breath, your body, a system that balances itself moment by moment. These forms feel designed, too precise, too elegant, but they don't come from a blueprint. They come from rules, simple instructions, repeated, growth responding to space, energy seeking efficiency, feedback reinforcing structure. Fractals appear in rivers, in mountain ridges, in the branching of lightning. The same geometry, reshaped by scale. Spirals grow from logarithmic rules, each step proportionate, each turn built on the last. No planner, no architect, just mathematics, written into the fabric of growth. Feedback loops hold everything together. Predators balance prey. Forests breathe in carbon, exhale oxygen. The earth warms, ice melts, oceans shift, climates adjust. Not stable, but dynamic. Never perfect, but persistent. It's easy to look at these patterns and assume intention, because repetition feels purposeful, because symmetry feels crafted. But maybe they're just the language of physics, the way energy moves, the way matter organizes, the way life finds forms that endures. When you see veins in a leaf, you're also seeing rivers on a map. When you see a spiral galaxy, you're also seeing the curl of a shell. When you hear the rhythm of breath, you're also hearing the rise and fall of tides. Nature repeats itself over and over. Different scales, Different settings, the same motifs, as if the world is sketching with the same hand on different canvases. And here's the thought: if our digital agents create flocking, swarming, emergent designs, and nature creates fractals, spirals, feedback loops, then maybe the line between artificial and natural is thinner than it seems. Maybe both are outcomes of rules. Rules written in code, rules written in physics, different sources, same results. Parallels stretch across realms. What looks intentional in nature may just be what happens when rules repeat. Not proof of design, but the echo of processes that favor structure over chaos. So when we see a spiral or a fern or the endless rhythm of waves, we don't just see beauty, we see the rhyme of reality, a pattern that insists on repeating itself, whether by design or by emergence. If Earth were designed, why does it feel so awkward? Think about the human body. The spine curves, but not in a way that suits standing tall. We borrowed it from creatures that walked on four legs. Now it carries the weight it was never built for. Back pain is the price. The eye is another puzzle. Light enters, but the wiring runs in front of the retina, a blind spot in every view. An engineer wouldn't place it there, but evolution reuses, reshapes, repurposes, not redesigning from scratch. Or the throat, air and food share the same narrow passage. Convenient, efficient, but also dangerous. A single mistake and choking can end a life. Not perfect, just workable. The same awkwardness appears in nature itself. Ecosystems collapse, forests burn, species vanish. Balance exists, but it's fragile. One shift, one missing piece, and the whole network can unravel. Earthquakes split the ground. Volcanoes bury landscapes. Hurricanes flatten cities. If this is a design, it's not designed in the sense of safety or comfort. Its design tolerates destruction as part of the system. Even orbit and tilt have quirks. Seasons change, sometimes gently, sometimes harshly. Ice ages sweep across continents. Deserts spread. Rainforests drown in storms. Life adapts, but never easily. If someone designed this world, they didn't smooth out the edges. They left the risks. They left in the sharpness. A perfect world would never choke its children, never bury whole cities in ash, never send storms rolling endlessly across the sea. And yet, the awkwardness works. The spine still holds. The eye still sees. The throat still swallows and breathes. Most of the time, forests regrow. Species shift. Life returns. Maybe the point isn't perfection. Maybe the point is persistence. A system doesn't need to be flawless. It only needs to last. It only needs to pass on what works. Not beautiful. Not ideal. Just enough. That's the difference between blueprint and process. A blueprint assumes foresight. A process tolerates mistakes. Nature looks more like a process. Messy, inefficient, but durable. The awkwardness tells a story. A story not of clean design, but of tinkering, trial, error, reuse, improvisation. A design that grows itself without ever erasing the flaws. So why not perfect? Because perfection isn't required. Because flaws don't stop survival. Because even broken structures can carry life forward. The earth is not a machine polished to shine. It's a patchwork, layered, imperfect. And somehow, that's what makes it work. In nature, survival always wins. Not elegance. Not beauty. Not even efficiency. Look at wings. Bird wings. Bat wings. Insect wings. They all fly, but none were built from scratch. Each is a reshaped limb, a modified structure, a hand or shell that found a new use. Not elegant, but good enough to rise into the air, The same with our bodies. The human brain is powerful, but it runs on wiring that's been reused for millions of years. New layers stacked on old ones. A thinking mind, balanced on instincts, on fight or flight, on hunger and fear. Messy, conflicted, but good enough to build language, tools, and cities. Evolution never starts over. It edits what's there. A fish fin becomes a leg becomes a wing, a jawbone becomes part of the ear. Each change carries traces of the old design, half-finished solutions, awkward compromises, but enough to survive the moment. Even ecosystems follow this rule. A forest burns, another grows in its place. Not the same, not perfect, but good enough to keep life going. Good enough explains the flaws. The spine that aches, the teeth that don't fit, the blood vessels twist and knot. If life had been engineered for elegance, these things wouldn't exist. But they do, because they worked well enough to pass on genes. That's the only test that matters. Survival doesn't care about comfort. It doesn't care about beauty. It doesn't care about us wishing things were smoother. It only cares that a system continues, that it persists just long enough to leave a trace in the next generation. Think about the immune system. It's brilliant, but chaotic. Sometimes it attacks invaders. Sometimes it attacks the body itself. Autoimmune disease isn't elegant, but the system as a whole often works enough to keep species alive, so it stays. Think about DNA. It copies itself with tiny mistakes, errors, mutations. Most are useless. Some are harmful. But every so often, a mistake makes survival easier. That's enough. The process continues. Good enough design is not design in the human sense. It's not polished. It's not optimized. It's improvisation. A rough draft that never gets rewritten, only edited in the margins. And yet, this roughness works. Life has lasted billions of years. Not because it's flawless, but because it never needed to be. Good enough kept being enough. So, when we ask why Earth isn't perfect, the answer might be simple. Perfection was never the point. Durability was. Persistence was. The ability to bend, to break, to heal, to try again. Good enough is survival. And survival is the only elegance nature requires. Pain feels like a flaw, like something that shouldn't exist. A broken bone, a burning cut, the ache of hunger, the sharp sting of loss. Why would any design include this? But look closer. Pain is not just suffering. It is a signal. It warns. It teaches. It says, stop, move, change. Without pain, a hand would stay on fire. A body would walk on a broken leg. A wound would rot unnoticed. Pain hurts, but it keeps us alive. It shapes behavior. Animals learn to avoid danger. Children learn what cuts, what burns, what bites. The entire species evolves by listening to pain, a lesson written in nerves, in reflexes, in memory. Even emotional pain has a role. Loss reminds us of value. Loneliness pushes us toward others. Fear keeps us cautious when the world is sharp. It feels cruel, but it's part of how life endures. Adaptation thrives on pressure. Without stress, there's no reason to change. Without scarcity, no drive to share. Without discomfort, no reason to seek better shelter, better tools, better ways of living. Nature's balance is harsh. Predators strike. Prey suffers. Famine drives migration. Ice drives invention. Suffering forces movement, forces invention, forces survival. That doesn't make it fair or kind. It makes it functional. A feature of systems that endure, not because they are painless, but because they respond to pain. Our own history shows this. Fire was not mastered in comfort. It was learned in the cold. Tools were not shaped for safety. They were made in hunger. Cooperation wasn't born from ease. It was born because survival alone hurt too much. In this way, pain is not the opposite of design. It is part of the structure, a mechanism that keeps life moving forward. Still, when pain feels close, when it feels endless, it's hard to see it as anything but a failure. That's human. That's real. We can hold both truths. That pain is brutal, and that pain is useful. The world doesn't hide its sharpness. It builds resilience through it. Every scar is a memory. Every ache is an adaptation. Pain writes survival into the body. So, maybe the better question isn't why pain exists. It's what keeps it alive. And as we sit with that thought, take a breath. You've made it this far. You've adapted too. That's no small thing. If you're still with me, still drifting through these questions, don't forget to subscribe so you won't miss the next quiet journey into the strange patterns of our world. It's easy to imagine a different Earth, one without pain, one without hunger, one where every system works smoothly, without collapse, without cost, a world where bodies don't break, where the spine never aches, where eyes see perfectly, without blind spots, where disease never strikes, where aging never comes, a world where ecosystems never fail, no extinctions, no storms, no floods or quakes, only balance, only peace. In those imagined worlds, everything feels intentional, a perfect blueprint, no rough edges, no compromises. Every part serves its purpose, without error. It sounds beautiful. It sounds fair. It sounds like design at its best. But pause for a moment. Would that world move? Would it change? Would it grow? Because of pressure, discomfort, even disaster. They are the engines of adaptation. Take them away, and maybe you take away the story too. A perfect body might never invent medicine. A perfect climate might never push migration. A perfect life might never need imagination. What would curiosity be without obstacles? What would progress be without struggle? Would we even dream of better worlds if the one we had already seemed flawless? Still, the dreaming matters. It shows something deeply human. The refusal to accept pain as the only way. The courage to picture more. To build systems that soften life. Antibiotics, shelter, shared knowledge, cooperation. We imagine better worlds, and in small steps, we make parts of them real. Vaccines, clean water, safer cities, the slow bending of possibility. The dream itself is part of survival, not because it's accurate, but because it fuels change, a vision to move toward, even if perfection never arrives. So we hold two Earths at once, the one we live on, messy, fragile, full of flaws, and the one we dream of, smooth, safe, whole. The tension between them is what keeps us building. Every improvement starts as imagination. Every solution begins as a dream. Better shelter, better medicine, better lives. Not perfect, but closer. Maybe that's the hidden gift of imperfection. It makes us restless. It makes us reach. It makes us draw blueprints for worlds that don't exist yet. And even if they never arrive, the dreaming itself reshapes this one. So tonight, as you drift, let your mind wander to those imagined Earths, the flawless ones, the gentle ones, not as an escape, but as an echo of what drives us forward. Because in the end, our ability to dream of better worlds is itself part of what makes this world extraordinary. If perfect worlds are so easy to imagine, why not this one? Why didn't Earth come built? Without cracks, without pain, without loss? The answer may be simpler and harder than it first seems. Trade-offs. Every system that works carries a cost. Every gain requires a compromise. Take the human spine. It lets us stand upright, walk far, carry tools, see across wide horizons. But the cost is a strain. Back pain, slipped discs, fragile balance. One advantage opens a weakness. Or the eye. It gathers light, tracks motion, reads words on a page. But the optic nerve leaves a blind spot, a flaw baked into the structure. Vision survives not by perfection, but by the brain filling in gaps. Nature reuses what works. It doesn't start from scratch. It adapts, step by step. And each step leaves traces of the last, good enough to survive. Not perfect. Never perfect. Ecosystems work the same way. Forests rise, then burn. Grasslands thrive, then freeze. Species flourish, then vanish. Collapse isn't an error. It's part of the cycle, clearing space for what comes next. If Earth were flawless, maybe it would be rigid, too rigid to change, too rigid to bend under pressure. And without bending, there is breaking. Without breaking, there is no growth. Complexity itself demands trade-offs. Energy is finite. Time is finite. Resources are finite. Spend energy on strength, and you sacrifice speed. Spend energy on intelligence, and you sacrifice simplicity. Even the most intricate designs are chains of choices. Gain here, lose there. Perfection would mean no trade-offs. But no trade-offs might also mean no complexity, no creativity, no evolution. A flawless Earth might last for a moment, but could it adapt? Could it respond? Could it give rise to beings who ask questions at night, who wonder why things are the way they are? Maybe not. So the question shifts. Not, why isn't the world perfect? But, why does this version work? Flawed, yes. But alive? Unstable, yes. But ongoing. That's the quiet logic of nature. Not a clean design. Not symmetry without cracks. But a system that holds together just enough to keep going, to keep changing, to keep surprising itself. So, when we dream of those better versions, smooth and gentle and flawless, remember this: without trade-offs, there might be no story. And without the story, there might be no us. Up close, flaws dominate. A sore back, a storm that destroys, an extinction that feels final. Zoomed in, everything looks fragile. Everything looks broken. But step back, widen the frame. Time stretches. Space expands. Patterns emerge. A forest burns. But, in decades, saplings rise. In centuries, new ecosystems take root. A species vanishes, but niches open. Other species adapt. Life continues, reshaped but unbroken. Earth is not about moments. It's about cycles, growth, collapse, renewal, loss, adaptation, continuation. What looks like a disaster in the short term becomes resilience in the long term. Glaciers carve valleys, floods redraw rivers, volcanoes bury land in ash, but those same forces create fertile soils, new lakes, habitats that will last thousands of years. The same is true for us. Human pain feels overwhelming when lived in days, hours, minutes, but over generations. It is memory, lesson, story. Evolution doesn't aim for comfort. It aims for survival, and survival plays out, not in a single lifetime, but across millions of years. That is the scale of perspective. Step back far enough, and even imperfection looks like a pattern. Blind spots fade into vision. Collapse blends into cycles. Flaws turn into trade-offs that make complexity possible. From a distance, the world is not broken. It is balanced. Messy in detail, resilient in some. Maybe that's why the question of design feels so slippery. At one scale, things look careless. At another, they look impossibly precise. The truth might be that both are real. Flaws at the small scale, patterns at the large, fragility in moments, resilience in ages. The eye can see a crack in the stone. The mountain, from far away, still stands. And Earth itself, over billions of years, still spins, still circles the Sunday, still carries life through every disaster. Zooming out doesn't erase the flaws, but it puts them in context. It shows how the broken parts hold together, how the unstable moments feed into long-term stability. That is the strange strength of Earth. Not perfection, but persistence. So when you feel the cracks, step back, shift scale, see the wider pattern. It may not be flawless, but it lasts, and lasting, in the end, might be the closest thing to design we'll ever need. At first glance, the world looks random. Storms strike without warning. Rivers change course. Mountains collapse. Chaos seems everywhere. But look again. Inside the noise, patterns form. Clouds swirl into spirals. Rivers branch like veins. Mountains rise in ranges, not scattered at random. Order emerges, even without a central plan. No architect drew the spiral of a galaxy. No engineer mapped the branching of a tree. No committee decided that snowflakes should carry six-fold symmetry. And yet they do, again and again, across time, across space. Why? Because of simple rules, repeated endlessly, create structure. Gravity pulls. Water flows downhill. Ice crystals lock together at certain angles. From those rules, patterns emerge. It looks like an intention, but it doesn't require intention. Randomness feeds order. Order emerges from randomness. The roll of atoms, the scatter of dust, the spin of particles. From these, a universe of structure. Think of dunes. Each grain moves at random. Wind tosses, shifts, drops. But step back. The dunes ripple in waves, as if sculpted. Or think of birds in flight. Each bird reacts to neighbors. Small adjustments, tiny shifts. No leader needed. But the flock flows as one, weaving across the sky, like a single living thing. This is emergence. This is a structure without a blueprint. Even our own bodies. Cells divide. Signals spark. No single cell knows the plan. Yet together they make eyes, hands, thoughts. It feels designed, but it may be something else. Order arising. Because randomness has rules. Nature loves feedback. Cycles build on cycles. Rivers carve valleys. Valleys guide rivers. Ice shapes climate. Climate guides ice. The loop tightens. Patterns settle. From randomness comes with stability. From chaos comes rhythm. And maybe that is the point. The world doesn't need a blueprint. It just needs rules. Rules that run and is over and over until the order appears. The strange thing? It works. Galaxies spin. Planets orbit. Life evolves. Not because someone drew it, but because rules repeat. Randomness and order woven together. Not enemies, partners. The cracks in the system don't erase the pattern. The noise doesn't erase the song. The world is both chaotic and structured, broken and whole, messy and precise. That might be the deepest design of all. A universe that needs no designer, because order is the natural child of chaos. Science asks questions. It measures. It tests. It builds models. But science has limits. It can show how. It can hint at why. But it can't reach every edge. At the edge, belief begins. Some call it faith. Some call it intuition. Some call it philosophy. Whatever the name, it's the place where answers thin out and questions grow larger. Science can tell us how stars are born. It can describe fusion, gravity, time. But when we ask, why is there something instead of nothing? The trail ends. Science can describe DNA. It can map genes. It can model evolution. But when we ask, why does life want to continue at all? The silence is louder than the data. This is the boundary, the edge between explanation and wonder. People have always lived at this edge. Ancient cultures filled the gaps with gods, with stories, with myths, not as mistakes, but as bridges across the unknown. Even today, we still do it. We may not name gods, but we name forces, principles, purposes. The human mind doesn't like emptiness. It fills it with meaning, and maybe that's not wrong, because science itself is built on faith of a kind, faith that the universe is regular, that tomorrow the laws of physics will still apply, that math works everywhere. We can't prove that absolutely. We assume it, we trust it, and so far it holds. But what about the places where can observation not go? Before the Big Bang, outside the universe, beyond time itself, there belief stretches its hand. Some believe in design, some believe in chance, some believe in cycles, worlds without end. Science can't stop belief. Belief can't replace science. They meet at the boundary, sometimes clashing, sometimes blending. The real danger isn't belief. It's forgetting the boundary. When science claims certainty beyond its reach. When belief claims proof without evidence. But when each holds its place, a balance forms. Science gives us a method. Belief gives us meaning. Together, they shape how we live with mystery. Because mystery isn't going away. The more we learn, the more edges appear. Each discovery opens a door to 10 more questions. That's the rhythm of knowledge. Progress on one side, wonder on the other. So, was Earth designed? Science can show probabilities. It can measure fine-tuning. It can explore emergence. But when we reach the final why, belief steps in, not as an answer, but as a companion to the question. Boundaries don't stop us. They remind us we are explorers, and explorers always walk to the edge of the map, and when the map runs out, we keep walking anyway. Science is not here to tell us why. It is here to tell us how. That distinction matters, because why implies purpose. Why implies intention. Why looks for meaning. Science doesn't chase meaning, it chases patterns. It chases predictions. Drop a stone. It falls. Gravity explains how, but gravity doesn't answer why gravity exists. Look at DNA. Science shows us how nucleotides pair, how replication works, how mutations lead to change. But it doesn't say why life seeks to persist. This is the core of science. Prediction over purpose. That might sound limited, but it's powerful, because prediction gives us control. Not ultimate control, but enough to shape outcomes. We can predict the orbits of planets, so we send spacecraft to meet them. We can predict chemical reactions, so we create medicines, plastics, and fuels. We can predict disease spread, so we intervene before it grows. Science thrives on this cycle. Observe, model, test, repeat. Each success builds trust, not in meaning, but in reliability. It doesn't matter if we understand the deepest why. If the formula works, we can use it. That's enough to build bridges, computers, airplanes, and vaccines. But science stays humble. It knows its edges. It knows the why question belongs elsewhere. Does that make it incomplete? Maybe, but incompleteness isn't failure, it's focus. Imagine asking, why does a tree grow? A biologist answers with cells dividing, nutrients flowing, sunlight fuels photosynthesis. That's not meaningful. That's the mechanism. And the mechanism is what lets us predict, plan, interact. Without science, we'd be left only with stories. Stories that comfort, but don't always work. Science doesn't take away mystery. It reframes it. It says, here's what happens next if we change this variable. That power to forecast, that's what makes science different. And yet, science itself doesn't close the bigger question. It doesn't say why the constants of physics exist. It doesn't explain why reality is comprehensible at all. Some find that frustrating. Others find it freeing, because it means we can use science without demanding it carry the weight of meaning. It can describe, measure, predict, and that is enough to keep us alive, to keep us curious, to keep us reaching farther. Science is not the story of purpose. It's the story of possibility. It doesn't ask, why are we here? It asks, given that we are here, what happens next? And that question is always open, always unfolding. So, when we talk about design, science can map the patterns. It can test the probabilities. But the moment we ask, why like this? We step beyond its role. Science lights the path, but it leaves the horizon open. Science explains how, but it often leaves us asking, why? That's where faith enters. Not always religion, not always tradition. Faith can be broader. It can mean trust, hope, story, meaning layered onto the mechanics of life, because humans don't live on prediction alone. We live on connection. We want to know what it all means. Why do we suffer? Why do we love? Why does beauty move us when it has no survival value? Science describes the processes. Faith offers the frame. For some, faith is God, a designer who intended it all. For others, it's philosophy, a belief in order, in harmony, in universal law. For many, it's a blend, family stories, cultural traditions, quiet rituals. Faith answers differently from science. It doesn't test variables. It doesn't predict experiments. It comforts. It gives purpose. It turns accidents into lessons. It turns survival into destiny. Think of a night sky. Science says, those are stars, nuclear furnaces, light years away. Faith says, those are lights that guide us, a reminder of something larger. Science explains how a body grows. Faith answers why life feels sacred. One without the other feels unfinished, because too much science and the world can feel cold, like a set of equations. Too much faith and the world can lose grounding, floating beyond evidence. The two balance differently in different lives, but faith's role remains clear. It carries the questions science leaves behind, not in opposition, not always in conflict, but in parallel. Faith holds the idea that there is meaning, even when the mechanism feels indifferent. Earthquakes are just tectonic shifts, but faith lets us grieve. Let's say loss is not random. Illness is mutation, infection, biology. But faith lets us endure. Let's believe suffering isn't the whole story. Faith shapes identity. It ties us to community. It reminds us that we are more than cells, more than data points, more than evolutionary outcomes. Some find meaning in scriptures, some are in meditation, some in the quiet trust that the universe bends toward order. Even the choice to trust science is a kind of faith. Faith in consistency, faith in the method, faith that tomorrow's experiments will follow the same rules as today's. In that sense, faith is not opposed to reason. It is woven into every decision we make about how to live in an uncertain world. Faith answers not just how do things work, but what do they mean to us? And sometimes that meaning is what keeps us moving forward. So if science is the lamp, faith is the story told by its light. Science and faith are often placed apart, two worlds, two ways of knowing. But listen closely, and sometimes they sound alike. Physics at its edges feels like philosophy. Quantum mechanics speaks of uncertainty, probabilities, events that don't exist until observed. It doesn't feel mechanical. It feels mysterious. Relativity bends space and time. Time slows. Space stretches. Reality itself warps in ways no everyday logic can hold. It's tested, proven, yet still unbelievable. That's where science begins to echo faith, both admit limits. Both describe things beyond human intuition. Scientists call the universe fine-tuned, not because they mean a tuner, but because the conditions are so precise, so narrow, that a universe with life looks improbable. Believers call it creation. Both point to awe. Both point to wonder. Even language overlaps. Physicists describe laws as elegant. Biologists speak of beauty in systems. Cosmologists talk about origins with words like beginning and mystery. Those aren't just technical terms. They carry feelings. They carry meaning. In faith, people seek purpose. In science, people seek patterns. But when the patterns are surprising, when the math reveals hidden order, the reaction is the same: astonishment. Take the anthropic principle. Science says we observe a life-supporting universe, because only such a universe allows observers. Faith might say, we're here because it was meant to be. Different words, same question. And when science talks about multiverses, or simulations, or consciousness as more than matter, it starts to sound like belief itself, speculative, unprovable, yet deeply compelling. Faith doesn't vanish in the face of science. It adapts, it reframes, it listens and finds echoes. And science, at its most daring, doesn't strip away mystery, it expands it. Each discovery solves one riddle, but opens 10 more. That's the overlap. No agreement, not replacement, but resonance. A recognition that the tools may differ, but the impulse is shared. To know, to understand, to place ourselves in a story larger than us. So, when science whispers about origins, and faith sings about creation, the melody is different, but the rhythm is the same. We wonder where it all began. We wonder why it continues. We wonder what it means. That's the meeting point, not in certainty, but in shared questions. Science explains the stars. Faith wonders what they're for. Together, they leave us staring upward, not with answers, but with wonder. What if design isn't planned? What if it's not a blueprint, not a hand sketching every detail, but something that forms by itself? Think of a snowflake. No one designs it. No architect decides its shape, yet every crystal grows with symmetry, delicate, precise, as if it were carved. Or, think of a river. Water finds its path downhill. No engineer lays the plan, but the valley forms, the meanders twist. The shape looks purposeful. That's emergent design, order without a designer, patterns shaped by constraints. In nature, constraints are everywhere. Gravity pulls, heat rises, atoms bond, energy flows. These rules don't choose. They limit, they guide. And from those limits, forms appear. A spiral galaxy, a branching tree, a seashell that curves just so. Not imposed from outside, not commanded, but inevitably, given the conditions, life itself may be like this. Not designed in advance, but rising from chemistry. Molecules combine, replicate, compete. From that, evolution. From that, eyes, wings, forests and minds. It feels like design, but maybe it's emergence. Because when systems run long enough, when feedback loops shape outcomes, when trial and error repeats for eons, structures appear that seem chosen, but they weren't chosen, they were discovered. Even human design often works this way. A city grows around roads, markets, water, no single plan, yet order forms. Language evolves from use, not from committee, but from countless voices, layered over generations. The result feels intentional, but the process is open-ended. So, maybe Earth is the same. Not a perfect plan, not flawless engineering, but constraints plus time, rules plus accident. Emergence, mistaken for design, the balance of air, the distance to the Sunday, the cycles of water and carbon. They seem arranged, but maybe they're the outcomes that could survive, the ones that lasted, the ones we notice because we're here. This doesn't diminish the beauty. It deepens it, because it shows how much can rise from so little. From a handful of laws, from atoms and energy, from persistence. Emergent design is humbler than planning, but it's also more astonishing because it suggests that order isn't rare. It's natural. It's the default when systems have room to grow. Maybe designed isn't the right word. Maybe the right word is shaped. Shaped by physics, by chance, by persistence. And maybe that's enough, not less wondrous, but more, because it means the universe holds within it the power to create design without ever needing a designer. Design suggests intention. That's usually how we think about it. If something looks built, then someone must have built it. A clock has a maker. A bridge has an engineer. A painting has an artist. So when people look at Earth and see balance, symmetry, cycles that sustain life, the next question follows. Why? If it was designed, was it designed for us? Was there a purpose, a goal in mind? Purpose is a human word. We attach it to tools, to projects, to stories. A knife is for cutting. A chair is for sitting. A story is for meaning. But does nature work that way? Or are we projecting our own habits onto the cosmos? Because the purpose is hard to find in earthquakes, in diseases, in extinction, in suffering. Those don't look like part of a kind design. They look indifferent. So maybe design, if it exists here, it's not about kindness. Maybe it's about possibility. A system where life can happen. Not perfectly, not safely, just enough to keep going. Still, the question of purpose lingers. We feel it under the stars. We feel it in quiet moments. Why this? Why here? Why us? Religion has often answered, because it was intended, because life is the point, because creation had a reason. Science answers differently, because conditions allowed it, because time plus physics plus chemistry made it possible. No reason beyond that. But even science doesn't erase the question. It just reframes it, because we still wonder what it means, that the universe can produce wanderers, that matter can reflect on itself, that awareness exists at all. If design implies intention, then the intention implies a mind, and if there is a mind behind it, we are left to guess at its goals. Survival? Diversity? Awareness? Or nothing we can imagine? If there is no mind, no plan, the purpose may be something we invent ourselves, not given, but created. Maybe Earth doesn't need a purpose. Maybe life doesn't either. Maybe it's enough that it happens, that it continues, that it opens space for reflection. Design or not, purpose may be a question only we can ask. And maybe that's the point. Not to find the answer, but to keep asking. Because in the act of asking, we give the universe something new, a layer of meaning it didn't hold before. So, does Earth having design imply intention? Not always. Sometimes design means consequence. Sometimes it means an accident. Sometimes it means survival. But intention, that part might be ours. We want answers. Clear, final, satisfying. But the world doesn't always give them. The stars don't explain themselves. The ground doesn't tell us why it shakes. The body doesn't reveal its secrets easily. So we live with questions. Some small, some enormous, some that stretch across lifetimes. Is Earth designed? Or did it emerge? Was there an intention? Or just a consequence? No one can say for certain. Not now. Maybe not ever. And that's uncomfortable. We like closure. We like stories with endings. We like puzzles that resolve. But uncertainty has its own beauty. It keeps curiosity alive. It keeps us searching, watching, listening. If all the answers were given, Wonder might fade. The night sky might feel smaller. The questions might stop. Uncertainty leaves space. Space for imagination, for stories, for science, for faith. Some fill that space with gods, some with physics, some with silence. Each way is a response, a way of holding the unknown. Uncertainty doesn't mean ignorance. It means openness. It means admitting that the universe is bigger than what we can pin down. It means living in a world, that still has a mystery. And mystery isn't always a problem. Sometimes it's the reason to look closer. Sometimes it's the reason to keep going. The ocean is still vast. The mind is still deep. The universe is still unfolding. To live with uncertainty is to live with possibility. Maybe Earth was designed, maybe not. But here it, island. And here we are. We breathe. We think. We wonder. And in that, we participate in the mystery itself. Answers might come someday, or they might not. Either way, life doesn't wait for certainty. It goes on. The seasons turn. The rivers flow. The stars rise and fall. We don't need final answers. To live fully, we don't need certainty. To be curious, we don't need closure. To feel awe, uncertainty can be frustrating, but it can also be freeing. It means there's always more to ask, always more to learn, always more to imagine. Maybe that's enough, not knowing everything, but being awake to what island. So we rest tonight, with questions still open, not solved, not closed, but alive. And tomorrow, the wondering continues. Maybe the real gift isn't the answer. Maybe it's the fact that we're here to ask, to sit under a night sky, to notice the stars, to feel the ground underfoot, to sense its age, to hear the rhythm of breath, to know it continues. Awareness itself is rare. The universe is vast, and most of it is silent. Rocks don't wonder, flames don't question, rivers don't reflect. But we do. We see patterns in clouds. We trace stories in constellations. We watch the seasons turn and ask why. Presence is fragile. It slips away in noise, in habit, in distraction. But when it returns, everything sharpens. Colors feel deeper. Time feels slower. The world feels alive. Being here isn't just about location. It's about attention, noticing the small things. The way leaves bend toward light. The hush before dawn. The curve of a fossil in stone. Some call that mindfulness. Some call it awareness. Some simply call it living. Design or chance, it doesn't matter in these moments. The point is that we're able to notice at all, to stand in the middle of a mystery and feel part of it. Awareness connects us to each other, to the planet, to the cycles still unfolding. It reminds us we're not separate, but woven in, breathing the same air those trees exhale, drinking the same water that glaciers once released, carrying in our bodies the remnants of stars. Presence isn't permanent. It fades, it drifts, but it can return with a pause, with a look upward, with a single deep breath. What matters isn't having the final theory. What matters is being awake to the fact that we exist in this vast system at all. The earth tilts, the seas rise and fall, the winds shift, and here we are, noticing. That may be the greatest design, or the greatest coincidence, or both. But either way, awareness itself is astonishing. So, as the question lingers, designed or discovered, hold on to this. You are here, present, able to see, and sometimes that's the only answer needed. Take a slow breath. Let it fill you. Let it leave you. The earth continues. Whether it was designed or not, whether intention guided it, or chance shaped it, the planet is still here. It sustains life. It sustains thought. It sustains the story. Rivers carve paths over millennia. Mountains rise and crumble. Oceans pulse with tides. Storms sweep across continents. Yet somewhere between chaos and order, life persists. And here we are, thinking about it, breathing, dreaming, building meaning from atoms, air, and water. The sun rises. The moon pulls the tides. The seasons turn. And in those rhythms, we find a place for reflection. Calm reflection isn't about solving everything. It isn't about proving design or randomness. It's about noticing that there is a system and we are part of it. We tell stories about the stars. We chart the movements of planets. We map our history, our culture, our own small minds. Against vast time, this planet gives us space to think, to rest, to imagine. Even in imperfection, it holds us. The air we breathe carries traces of oceans and forests, of creatures long gone. The soil beneath us remembers floods, fires, and glaciations. The patterns of wind and rain, day and night, shape the rhythms of our own lives. Reflection reminds us that survival and thought are intertwined. That awareness itself is a gift. It allows us to build. It allows us to dream. It allows us to sit quietly and simply be. Even if life is fragile, even if systems fail, there is room to rest, room to appreciate, room to ask questions that may never have answers. We are small, and the earth is vast, but in this calm, we find a bridge between what is and what we imagine, between what happens by chance and what seems guided, between the measurable and the meaningful. So, let yourself breathe slowly. Let the quiet of the night settle. Let the stars, the wind, and the unseen forces of this planet remind you that you exist within something much larger. Whether the earth was designed or emerged, whether it was planned for life or simply allowed it, the result is the same. A place where thought happens, where stories can be told, where rest is possible. And in that realization, there is peace, there is gratitude, there is wonder. The earth will continue, and so can you. Breathing, reflecting, aware of the gift of being here, in a system that sustains thought, story, and rest. Good night. Slowly, let your eyes close. Let the world around you fade into quiet. The hum of life, the pull of the earth, the rhythm of day and night. All continues without rush, without pause. The air still moves. The oceans still turn. The sun will rise. The moon will pull the tides. And through it all, the planet keeps its balance, whether by design, chance, or something in between. You've travelled through ideas tonight. Patterns in nature, the eye, the delicate systems that hold us, the cycles of planets, life, and even thought itself. All of it is part of this vast, ongoing story. And now, as you settle, you become part of it too. There's no pressure to know everything. No need to have answers. It's enough to notice, to breathe, to exist in the quiet of a living, moving earth. Every breath you take connects you to trees, oceans, clouds, and stars. Every heartbeat echoes the rhythms of life. That began long before you and will continue long after. And in this awareness, there is comfort. Not because the world is perfect, but because it endures. Not because we understand every detail, but because we are here to witness it. Some things will always remain mysteries. Some patterns will never fully reveal their origin. And that's okay. You can rest in the space between knowing and wondering. You can let the questions drift softly at the edges of your mind. The earth doesn't need our validation to continue. Its systems turn, evolve, and adapt, and so can we, in our own rhythm, calm, slow, present, watching, breathing, dreaming. Before you drift entirely into sleep, remember this moment. You are part of the story, a small, aware piece of a complex, unfolding system. And just being aware, just noticing, it's enough to be connected to it all. If tonight's journey through ideas, patterns, and questions helped you pause, reflect, or feel wonder, consider subscribing. It's a gentle way to keep exploring, to keep noticing, to keep being part of this quiet, magnificent system.